Hi folks, Mr. Long here. Today I'm going to go through examining the graph of f prime at x, the tangent slope function, to get information about the original function f of x. So let's take a look at this. So this graph that's given here is the graph of f prime of x, the slope. So for example, all these y values are negative. That means the original graph is sloping down. All of these values are positive, which would mean the original graph would be sloping up in that interval. Here, the graph is sloping up, up, up. It's not sloping up at all, and then it does like so. So here's the first thing I would always do on one of these questions is this. I would take this graph, and underneath it, I would sort of rough sketch what the graph's doing. So if I look at 0 here, I know that it appears to be no slope, so it's kind of flat. All the way from 0 to 2, the graph is decreasing. Okay, so now like 0 there, so it's decreasing from there to there, all the way to 2. And then at 2, it goes flat because the slope is 0. Then it increases all the way to 4. Okay, this isn't what the shape of the graph's going to be. It's going to be curved, but at least we have an idea. And then from 4 down to, it looks like, I don't know, 4.5, it's decreasing. Okay, it's decreasing. Then something happens, there's a jump, right, from here to here. And at that point, the function is now sloping up again. We don't know how or what, but we know it's sloping up. It slopes up to 5. At 5, the slope there is 0, right? The y value is 0 on this graph, so it goes 0, and then it slopes up again, okay? So that's a rough idea of what the graph would look like, okay, approximately. And you should always do that. All right, let's go through and look at our questions. First thing we always want to do is take a look at where the tangent slope is not defined, okay, where the tangent slope is not defined. And I'm going to do that with a highlighter. Remember that we need local linearity, which means the slope has to be the same on both sides of the point. So if you have a point, oh yeah, here's the point right here. If you have a point, then for the graph to have a slope, for the slope to be defined, it has to be the same on the right and on the left side of that point, okay? The slope has to be the same. So some situations where that doesn't occur is, what if you have a point and the graph only exists to the right? Well, if the graph only exists to the right, there can't be slope at that single point because there's no local linearity. Local linearity means the graph has the same slope infinitely close to the point on both sides of the point. Okay, there's other cases. What if you had a point here and your graph came down like this and like that? Well, clearly it does not have the same slope right there as it does right there. So there's no local linearity. Remember, local linearity is defined when you zoom in on it a lot. Okay, folks, so where can't this curve have a tangent slope? Right there, because it's only defined on one side. Right here. Now, by the way, this is the value of f, sorry. These are graphs of f. This is a graph of f prime. Okay, a graph of f prime. And so, whoa, so folks, there is a tangent slope here, right? Because it's the same slope on either side. Here, remember, this is the tangent slope function, so the slope is the same on either side, right? So this is the graph of f prime, not f, okay? So, and then here, though, the slope goes from negative to positive, right? So when you have a tangent slope function that looks like this, what would the original graph look like? Something like that, right? Because the slope is switching from a negative to a positive, right? So if the tangent slope function looks like this, it's going to have something like that, some sort of corner, okay? And then, and that's it, okay? So the only spots where we can't calculate slope, this isn't a huge deal, not getting this, but right there as well. Okay, stationary points. What are stationary points? Stationary points are when f prime equals 0. Well, where does that occur? It seems to occur there, but since there's no local linearity, there's no graph on the other side, I can't count that. Definitely there, Okay, f prime is equal to 0 there, f at 2, f prime at 2, and f prime at 4, and f prime at 5. Okay, so f prime at 2 equals f prime at 4 equals f prime at 5 equals 0. Okay, where is there a local maximum on the original graph? Well, to have a local maximum, there's a maximum, right? You'd have to have a positive slope followed by a negative slope. Or in other words, the tangent slope function would have to be 0 there in the middle, and then on the left side it would have to be a positive number, and on the right side it would be a negative number. So if this is f, this is what f prime looks like. Okay, that's a local maximum. Do we have any situations like that where the tangent slope goes from positive to 0 to negative? Well, the tangent slope here goes from negative to 0 to positive. Is that what I wanted? No. What about right here? The tangent slope goes from positive to 0 to negative. Look at this. There's your maximum, right? There's your maximum. Slope of negative slope to 0 to positive. That's going to be, or sorry folks, positive slope to 0 to negative slope. And that's going to give us a maximum, okay? A maximum. So if f prime looks like this, the original graph has a maximum. Okay, and that occurs, oh, what about this one? So this, the slope is positive, it goes uphill, then it goes to 0, and then it's still going uphill. So it goes uphill, horizontal, and uphill. Okay, so the only spot where that occurs is x equals 4. So for a minimum, f will look like this, right? And it'll have a tangent slope of 0. Before, on the left, it'll have a negative tangent slope. On the right, it'll have a positive tangent slope. So I'm looking for a graph f prime that goes from, it has 0. Before there, it has a negative slope. And after, right there, it has a positive slope. So it's an x-intercept where the function is increasing, okay, on f prime. Where do I have that? The only location where that occurs is at x equals 2. Negative slope, 0, positive slope. Okay, negative slope, 0, positive slope. It's really hard. You have to read these. The y value on this graph is the slope of the original. Okay, and that's only at x equals 2. Saddle points. Where are the saddle points on f at x? Saddle point is when f prime equals 0 and f double prime would also equal 0. Now, you're not at the point of being able to really read that off here, but we can kind of tell here because look at this. Remember, these are slopes. The y values in this graph are slopes. So the function is increasing before 5. It goes horizontal at 5 because y prime is 0 or f prime is 0, and then it increases again. Okay. That's our characteristic saddle shape. So x equals 5. Okay, what are the intervals where f, the original function, is increasing? Well, in this case, f prime of x is greater than 0 or above the x-axis. So where is it above the x-axis? I'm just going to erase right now all this stuff here. So we have a nice clear graph to work with. Okay, so actually, I don't even need to worry because I've already got this done right here. Look at this. In that first rough sketch. So when is the function increasing? From 2 all the way to 4. And then it kind of stops right here. It looks like at about 4.5, right? Yeah, that should have kept going down there a little more. So about 4.5, it switches from a negative to a positive. Okay, so that's, I would say 4.5. And then at 5, it goes horizontal. Okay, so when is it increasing? Well, not there. It's increasing from 2 to 4. and from 4.5 to 5, and then again after 5, but not at 5. At 5, it's 0, okay? So what's the interval going to be? So f prime of x is less than 0 or below the x-axis. And that's going to be, oh, I didn't state the interval for the last one. So this is going to be x equals, when is it decreasing? Oh, whoops. Hey, when is it increasing? It's increasing from 2 until 4. These will always have round brackets on them because the endpoints, it's neither increasing nor decreasing. It's a max or min usually, or a saddle point. So 2, 4, union 4.5 to 5. And then from 5 to 6, union again, 5 to 6. The reason why it's not allowed here or here, like at 5, it's a break because for an instant it goes horizontal. F prime is 0 there. It's neither increasing nor decreasing. And then when is the function decreasing? I'll do this in a different color. It's decreasing very obviously right there all the way to 2 because F prime is below the x-axis. And then it's decreasing again between 4 and 4.5, okay? So I go back to here and I write x equals 0, 2 union 4, 4.5. Okay, so I encourage you to watch this video again and look it over and make sure you understand everything. And then go through and do the rest of the practice. Okay, good luck.